And hi everybody, here's question 103 from chapter 5. For this question, we're asked about the evolution of oxygen gas by the decomposition of nickel oxide here. Alright, so we get 2 moles of nickel from that plus 1 mole of O2 gas. Right, and this is the species of interest here. Oh, whoops. This evolved gas here. So in this case, we're required to find the pressure by from a total pressure and some Dalton's law stuff. So this mentions that it's collected over water at 40 degrees Celsius. So whenever you see that over water bit with where you're dealing with pressures, don't forget that the vapor pressure of water has to be accounted for in here too. So we're going to find our pressure of oxygen via Dalton's law this way. We were given a total pressure, right? So we can subtract the table value of oxygen at 40 degrees Celsius, which is 55.365, right? And these are both torr values here. Okay. And that gives us a pressure of 689.635, right? That the oxygen's putting out. So now we can calculate the moles of oxygen from the moles of nickel oxide here. So let's do that over here on this side. So first let's start with our moles of nickel oxide. This we were given a mass for. So that is going to be 24.78 grams. That's how many we're given in the question. Divide that by the formula weight of nickel oxide, which is 74.69 grams per mole. And we'll calculate a total value of 0.33177 moles. Now, see that the stoichiometric relationship between nickel oxide and oxygen is 2-to-1, right? Meaning we're only going to have half this amount evolved in the gas, right? So the moles of oxygen are going to be that value divided by 2, right? Which is equal to, just give me a second, 31772. 165,885. All right, so we can now calculate our our volume of oxygen, which is what we're asked for in the question, because now we have temperature. We know it's at 40 degrees Celsius. We know it has this pressure. We know it has this many moles. That means we've got 3 of the 4 unknowns. We can solve for the 4th. All right, so nRT over P is 0.165885 moles times 8.314 J over mulk. Okay, 40 degrees, or is it 40 degrees plus 273? That's going to be 313.15 Kelvin. Okay, and we'll divide all that by the pressure, which was 689. That's supposed to be a 9. 689.635. And we'll put that in kilopascals. That's 100 over 750.06. Okay, that will cancel the moles. That will cancel kelvins. Kilopascals will cancel half of the kilopascal liter that this converts to, leaving us with liters of the total. And the torrs, if I had written them there, would be canceled out too. So that's just as well. This solves for a total of 4.70 liters. And that's our answer.